Okay, so today we're going to be talking about how do we do inverse trig. And you might remember from, say, in geometry where you said, hey, if I've got this shape, and it's a hill, and on this hill the hypotenuse is 10, and this was, say, 3, you did, let's see, the sine of a certain theta is equal to 3/10. And in order to solve this, you typed in your calculator inverse sine to say, let's undo sine to say, okay, if I unsine something, okay, and I want to get rid of sine, I get theta is equal to the inverse sine. And there's a button on your calc to do 3/10. And then you could do inverse sine and it would give you the angle measure that had that ratio for sine that was 3/10, because your calculator knows all the sine, cosine, and tangent ratios. And so to figure out the angle that goes with it, you do inverse sine, cosine, or tangent, and it'll tell you the angle that goes with it. And so the thing is, I love that, and we're going to use that in the next section or two when we're talking about things that are not special. But if we have items that are special where it's like, I'm thinking of a cosine being a half, since a half being cosine is something special, it's one of our 30, 60, 90s or 45, 45, 90 triangles on a unit circle, can you help me figure out, what values that would be? And so we can use our unit circle to work backwards to say, okay, if I look for the values where cosine is a half, which ones will they be? And it'll tell you in the directions where to look. Okay, so in these directions, it'll say cosine of a certain theta is going to be a half. Well, and they said look from 0 up to 360 degrees. So it says include 0, but does not include 360. You see the parenthesis there? And so you look at your unit circle and say, okay, my ratios are the ones that we talked about before, where sine is going to be the y, okay, y or y over 1, because it's a unit circle. So the sine is y. And the adjacent over the hypotenuse is going to be the x-coordinate. Okay, so that's cosine is x, sine is y. And if you want to talk about tangent would be y over x. And so you can write those down to say, okay, tangent is going to be y over x. And then, of course, cotangent would be x over y. Okay, and then we also have the secant and the cosecant. Well, the secant is going to be the reciprocal of the cosine, which is x. So 1 over x, you flip over the x-coordinate. The cosecant is going to be the reciprocal of sine, and so you flip over the y-coordinate. Okay, and so if you want to write down cosine is x, sine is y, this is going to be secant if you flip over the x, and then cosecant is going to be able to flip over the y. And so that could be like a shortcut for you guys. So where's cosine a half? So you go to your unit circle and you say, okay, if my cosine is a half, okay, that's going to be the x-coordinate. So look on the unit circle, say, where is cosine going to be half? And so that would be up here and also down here. And so you got to answer the question. It says in degrees. How do you know it's in degrees? Well, because it says look from 0 to 360. Okay, so if you go from 0 to 360 degrees and you answer the question, you say, okay, theta is equal to 60 degrees, and also it's going to be equal to 300 degrees. Now, if I ask you something that's not on the unit circle, obviously you're going to use your graphing calculator and be like inverse sine or inverse cosine to find the angle that does those weird things. Okay, where is sine going to equal negative square root of 2 over 2? Okay, so I think the first thing would be, okay, so you go to your unit circle and say cosine is going to, or sine is going to be the y-coordinate. So let's look and see where is sine going to be negative square root of 2 over 2. Okay, and so that is going to be the y-coordinate. So when the y-coordinate is negative, that's going to be on the lower half of the circle. Okay, so where sine is going to be that, it's going to be down at 225, and also it's going to be at 315 degrees. And so you're going to answer the question based on how they're asking and what they're asking for. So theta is equal to 225 degrees and then also 315 degrees. Okay, it says, where is tangent square root of 3? You're like, I don't see tangent on here. Well, this is where you kind of have to try things on. If you go clothes shopping, you've got to go try things on and be like, okay, how's this going to fit? What's the deal? And so you maybe know that if I ask you tangent of a 45, it's the ratio of the legs. And because the legs are going to be equal in a 45, they're going to either be 1 or -1 on the 45 degree angles. So you know it's going to either be 30 or 60. So, the more you do, the more you kind of can see. But the answer is going to be a 60-degree angle. How do I know that? Well, I've done it a lot of times, but also let's think about this. If you do y over x, okay, if you do y over x, okay, and so say that I grab these 60-degree angles, you're going to do y over x, which is going to be the square root of 3 over 2 over 1/2. And so, like I said before, if you got fractions and fractions, yes, you can do the do the division of it, but you can also say the denominators cancel out and you're going to get just the square root of 3 over 1, which does not need to be rationalized. And they just want it positive. If they wanted negative, you'd have to look in the other quadrants to figure out how would be tangent negative. Okay, that doesn't make sense, but how tangent would be negative. And so tangent being square root of 3 over just the square root of 3 would be a 60-degree angle in the first quadrant, okay? So that would be 60 degrees. It also would be, if you go to the third quadrant, if you write the ratio of the legs for tangent, y over x, you would see it would be a 60-degree angle also in the third quadrant, because if you write the ratio of two negatives over each other and you reduce them, you're going to see that you get also the square root of 3. Okay, and so that's going to also be 240 degrees. Okay, so the reference angles will be the same. The question is, what are we looking for? Okay, so the next thing would be, they said, okay, now that was really fun. I want you to look between 0 and 2 pi to see what the answers are going to be. So sine of a certain angle between 0 and 2 pi, including 0 but not including 2 pi, is going to be the square root of 3 over 2. So we have to say, okay, well, sine is going to be the y-coordinate. So let's look on our unit circle and say, where is sine, the y-coordinate, the square root of 3 over 2? And so that would be up here. And then also sine is going to be the y-coordinate. It's going to be up here. So the y-coordinate being positive is in the top half of the circle. And so you can see, hey, it's going to be both at 60 and 120 degrees, but they don't want it in degrees. They want it in radians. See how they ask it. So theta is equal to, and I will use a pen, not a marker. It would be pi over 3. And then it would also be 2 pi over 3. And so we're trying to become familiar with the unit circle, and we're going to be talking about in class outside of the notes to say, how can you memorize this? Because I'm going to ask you guys to recreate it, but I don't want you to memorize it. I want you to know the patterns so you can fill in what is true about a unit circle. Can you name the angles, the radians, and then also the ordered pairs? Okay, it really is just 3 special triangles whose ordered pairs are special. Okay, cosine of theta being the negative square root of 3 over 2. So that would be the x-coordinate. So we have to look to say, when is the x-coordinate going to be negative square root of 3 over 2? Let me erase this. Okay, so where would we look? Well, let's look at, I don't know why this isn't erasing, but we'll just go with it. Okay, so the cosine, the x-coordinate to be negative square root of 3 over 2. Negative square root of 3 over 2 looks like it's going to happen here and right here. So 150 degrees and also 210 degrees, but they want it in radians. So let's do this in radian measure. So it'd be 5 pi over 6, and then also 7 pi over 6. All right. The next thing is, where's tangent negative 1? Well, tangent being 1 is going to be a 45. Where's tangent negative 1? Well, that would be a 45-degree angle in both the second and fourth quadrant, because when you write the ratio of the legs, you want one positive and one negative to make them negative. So that would be 3 pi over 4, and it would also be 7 pi over 4. Because if you look at writing the ratio of the legs in the second and the fourth quadrant, you would get negative 1. Now, there are a couple ways to say inverse sine, inverse cosine, etc. And so one of them is sine to the negative 1. It's a play on words. People use it to be like, if I have, cosine of theta is equal to 10, 1/10, you would do the inverse cosine to solve that for theta. Okay, and so unsine, uncosine, untangent are going to be push that button on your calculator or tell me. It's kind of like inverse of like, I give you x, you give me y. In this case, they're saying, if I give you the fraction, can you give the angle who generated that? And so inverse sine of a fraction, so how you would see it would be, sine inverse of, say, a half, and you would say, okay, who has a sine of a half? Okay, and if you asked your calculator, it would know. Okay, it would be like, oh, it's 30 degrees. Okay, And if you look at the circle, you could come up with 2 answers that would give you those answers. Same with inverse cosine. Who has a cosine of this value? Another way to write this exact same thing is arc sine of 1/2. That means who has a sine of a half? You would say 30 degrees. And then you'd also, if it asks you for all the ones from 0 to 360, you would give all the answers from that. So inverse sine and arc sine are going to be 2 ways to say, if I give you a fraction, give you the value of sine, can you give me the angle who made it? Okay, all the angles within the group. Okay. And so we're looking at these to say, do I understand that? And I think the thing is, like, in the olden days when people had typewriters, you're like, yeah, I know that was a long time ago. Yeah, it was a long time ago. People didn't know how to do exponents as well. And that's why the books were very expensive for mathematics, because you had to be kind of fancy to cause things to be exponential. And so a way to not have to do an exponent would be they wrote the word arc sine and arc cosine and arc tan instead of saying tangent to the -1 or inverse tangent, inverse cosine. So they are synonyms, and they say, I give you a fraction, I give you the output, the result of sine, cosine, or tangent, and you give me the angle who created that thing. So it's working backwards. And so what I want you guys to be able to do is to say, can I answer the question? Okay, if I tell you to do sine, cosine, or tangent of an angle, can you figure out the fraction? If I give you inverse, if I ask you inverse cosine, inverse sine, inverse tangent, inverse secant, etc., can you give me the angle who made it? Okay, and so it's kind of a cute little game of working backwards and forwards for these types of things. Okay, and so I think the first thing would be, on these questions below to say, okay, what are they asking? Okay, and so let's start at number 9. Okay, number 9 says, okay, tell me the cosine of pi over 6. Okay, what is the cosine of pi over 6? So you go to pi over 6 on your computer or on your unit circuit and say, okay, cosine of pi over 6 is going to be the x coordinate at a 30-degree angle, and that's going to be the square root of 3 over 2. And then I said, that was so much fun. Now I want you to work backwards. I want you to tell me, where is sine, inverse sine? Where is sine? When does sine, what angle does sine have the square root of 3 over 2? Where does that happen from in quadrant 1? Okay. And so you're like, okay. So where is sine? Okay. Give me the angle where sine is square root of 3 over 2. And you would say, oh, that would be at 60 degrees. And a lot of times, to be fancy, they would say, give me pi over 3. So you could give either one of those as your final answer. So you're starting with a parenthesis 1, okay, and answer that question, and then do the next one that's outside of that. It's kind of like a little game. So if we go back to 8 and say, okay, inverse cosine of square root of 3 over 2. Okay, so it says, tell me the angle where cosine is the square root of 3 over 2. Okay, look in the first quadrant. Where is cosine the square root of 3 over 2? And we would say, oh, at 30 degrees or pi over 6. So you could do either one, 30 degrees or pi over 6. I'm going to write down 30 degrees because I know you guys would rather work in degrees if possible. So where is sine? And then they say, take the sine of 30 degrees. Okay, what is the sine of 30 degrees? Oh, that is a half. Okay, go to 30 degrees and answer the fraction sign. So you're looking to answer those questions as they're saying. Okay, so number 7 says, do the inverse tangent of square root of 3 over 3. Where is tangent that? Okay, give me the angle where that happens. And that would be at 30 degrees. Or pi over 6. And then they say, tell me, now that was fun, tell me the cosine of 30 degrees. Well, the cosine of 30 degrees is the square root of 3 over 2. Okay, so that is going to be your answer. Okay, so let's keep moving. The next one say, okay, let's start at number 10. What is the sine of a half? Pi over 2, I mean. Sine at pi over 2 is up at the top. Sine there is going to be, 1. Okay. Now they say do the arc tan. Okay, that means inverse tan. Okay, so where is tangent 1? Okay, that would be at 45 degrees. So you could say 45 degrees, or you could say pi over 4. They didn't tell us how they want our answer, so we get to pick. Okay, so the next one says, what is the angle where sine is 40 over 41? Okay, and you're like, you could do inverse sine on your calculator, but I think they're going to be a little tricky. Okay, they're saying, think about an angle where sine is 40 over 41. Okay, so that would be a picture where sine is that. And then I say, okay, now can you do cosine of that same angle? Okay, so give me the angle. I'm like, well, we'll call it theta. Okay. And they say take cosine of that value. Well, if you do the Pythagorean theorem, you'll find that this side is 9. So what is the cosine of that exact same angle? It's going to be 9/41. So that was a little tricky. You could use your calc to find out the angle and then take the cosine of it. But to be honest, you don't even need a calculator for this one right here. Okay, the next one says arc cosine. That means the inverse cosine. Where is cosine? This value. Okay. And again, instead of actually evaluating for that angle using your calculator, they just want us to do it. Okay. So the square root of 39/8. Okay. And they say, tell me the tangent of that value. Okay. So give me the angle. Okay. It's theta. And then I say do tangent. So if you do the Pythagorean theorem, you're going to go the square root of 39 squared plus x squared is equal to 64. Okay. Square root of 39 squared is 39. So minus 39 from both sides. You get x squared is equal to 5 or 25, which is going to give us 5. So this side is 5. So I said, tell me the tangent of that value. So tangent is going to be 5 over the square root of 39. Rationalize it, it'd be 5 squared of 39/39. Okay, so if they ask you something weird, draw a picture. Okay, because like they're saying, talk about that angle and then evaluate that function, a different function from that same angle's perspective. All right, thank you. Have a good day.